Bismillahirrahmanirrahim. Welcome to the new lecture of multimedia and technology. So today we are going to be learn about data compression. Okay. So the objective which we need to be study here is about distinguish between a lossless and lossy compression. Describe a run length encoding and how it achieves compression. Describe Huffman coding and how it achieves compression. Describe Lempel encoding and describe the main idea behind the JPEG. Describe the main idea behind the MPEG and describe the main idea behind the MP3. So we will cover this chapter in two lectures. So half lecture will be here in this lecture and half will be in the next one. So coming to what is compression principle. Okay, the first thing, why we can compress the data, you guys know, because once the data have in a large size, so what we are going to do, we are going to compress the data, because large size or large MB is not going to be easily be transferred, it takes time. So that's why we are going to compress the data. When we compress it, then we can easily transfer our data from one point to another point. So compression described to compress digital audio, image, video so that their bit rates or storage requirement become manageable. So once we compress all data, when we compress the data in the shape of audio, image, video, so what we can do, we can manage the data. We achieve data compression by exploiting two major factors. So the first one is redundancy existing in a digital audio, image and video. You know about redundancy. Once bits are going to increase, or once we have a lot of bits, or when we have a 2, 3, 4 kind of a video or audio, this is called redundancy. Redundancy means increasing. The second is the property of human perception. So what is the concept about the compression? The concept behind the compression is we can handle, we can manage the data. So data redundancy. Digital audio is a series samples value. You know about a digital signal, you know about a digital data, you know about now a digital audio. Again, digital audio always have a sample, so we will have a series of a sample. Let's see, this is here and we will have a series of digital sample. This is called sample. Upper, or you can make it down as well, so this is called, you can make it by this as well. Okay, so this is called digital audio is a series samples value. An image is a rectangular array of a sample value. Image is a rectangular array of a sample value, like a pixel. Okay. Video is a sequence of images played out at a certain rate. Now it's about video is the basically sequence of images, and images in the is a rectangular array, so it's like a combination of a two things. Okay. So this is the idiom from another language, and so what's mean redundancy. Removal of redundancy does not change the meaning of a data. Okay, once you are going to remove or once you are going to reduce the redundancy in a data, so it's not going to change the meaning of a data. Your data will be the same, but we just are going to reduce it, we are just going to remove the redundancy. Redundancy in a digital audio. In most cases, adjacent audio sample are similar. The next sample value can be predicted to some extent based on the current sample value. So it's about the adjacent audio sample. So it's saying that adjacent value, it's just like this is your this is one, this is another sample, so it will be same, but the third one will be depend on the first sample. Okay, so it's about the audio concept. Compression techniques that use this feature are called predictive coding. So what is predictive coding? The predictive coding is the sample, the adjacent sample will be like a similar, and the next one sample will be depend on the current sample value. So during a normal conversation, we talk for only a very small percentage of a time. Between a talking spurt, there is a silence. Samples corresponding to this silence can be removed without affecting the meaning of a speech. What does it mean? That once you are talking with someone, so once you are talking, and between the communication of two person, there will be a time for a silence as well. So what we are going to do, we are going to remove this silence bit, we are going to remove this silent duration from the data, but our data is not going to be changed because the data is based on your talking. Once you have a talking, you have a bit. Once both the customer or silence, so the silence duration is going to be reduced from your data. So this is called like a compression. So compression techniques that use this feature are called silence removal. Redundancy in a digital image. Now we study about redundancy in a digital audio. Now we are studying about digital image. So in a digital image, neighboring samples on a scanning line are normally similar. Neighboring sample on adjacent line are also similar. So these similarities are called spatial redundancy. So how we can remove the spatial redundancy from a data? So spatial redundancy can be removed using a predictive coding techniques and other techniques as well, about like a transform coding. Okay, so these are the techniques how we can reduce or remove the spatial redundancy. So redundancy in a video. Now so we study about audio, study about image. Now the time for a digital video. So a digital video is a sequence of an image. Digital video is a sequence of images, thus it also has a special redundancies as well. So neighboring image in a video sequence are normally similar. These similarities is called temporal redundancy and can be removed by applying predictive coding between images. So as we studied in audio we had a predictive coding. So same the predictive coding is applied in images, and the same predictive coding is applied in a digital video because of removing the redundancy of a data. Classification of compression techniques. So can be classified in a many ways according to different criteria. The first is classify them based on the result of the compression techniques. Two classification we will consider or whether the original data can be reconstructed exactly after using a compression techniques, and whether the output of a compression system is of a constant bit rate. So it's based on two. The first one is we can reconstruct our original data in the receiver end, the first, and the second is we can have our original data in a constant bit rate. Constant bit rate means our bit rate is not going to be changed. So the output will be the compressed system, but the bit rate will be the same. Bit rate will be constant, or we can say the bit rate will be uniform. So data compression techniques or methods can be divided into two broad categories. The first one is lossless and the second is lossy. So data compression methods, the first method is about lossless method. Lossless method is about texting or programs. Lossy method is where we have images, video and audio. So keep in mind, so once somebody is going to ask you about data compression method, so he said, okay, what kind of a method can be applied in the text or program? So you can say lossless, because in the text you are sending your bits, your text. So and second is lossy method for images, video and audio and so on. So lossless method have again a run length method, Huffman, Lampalziv, and a lossy method we have JPEG, MPEG, MP3 and so on. Okay. So coming to definition for lossless compression. So the integrity of the data is preserved. You know about integrity. What is integrity? So the data will be integrated. The original data and the data after a compression and decompression are exactly the same, because in these method the compression and decompression algorithm are exact inverse of each other, and no part of the data is lost in the process. Okay. So same in before compression and after compression or decompression, the original data will be the same. There will be no loss of your data, no loss of your bit, etc. Okay. So redundant data is removed in a compression and added during a decompression. So the same thing, redundant data is removed in a compression. When you are compressing, so your redundant bit is going to be removed, but once you are going to decompression again, then it again added with your data. So this method are normally used when we cannot afford to lose any data. So in a lossless compression we have a run length encoding. So what is a run length encoding? The simplest method of compression. The general idea behind this method is to replace consecutive repetition. Once we have a consecutive repeating, so we just replace it. A consecutive repeating occurrence of a symbol by one occurrence of the symbol followed by the number of occurrences. So what does it mean now? Let's come to this one. We have our original data. So our original data start from B. So if you can see, there is a consecutive repetition of a alphabet. Then we have a like A, then we have a N, then we have a M. So what we are going to do in a run length encoding, it's by name it's now it's a run length. So there will be a length of a data, and that data will be in a running form. So if you can see, this is a running form. So now what we are going to do, we are going to compress this data. So if you can see that once we compressed our data, so our result will be, so B9 mean that we have a B in a consecutive form, which is in the number of 9. So 1 2 3 4 5 6 7 8 9. So we have a B9, then we have a A16, 1 2 3 4 5 6 7 8 9 10 11 12. So A16. So then we have a N, so N is 1, then we have a M is 10. So if you can see, the bandwidth of a data so the original data is in large bandwidth. So once we compressed it, so the compression will be like, it's like a one part of a 1/4 part of our original data. So this is your compressed data. So once we are sending this compressed data to somewhere else, so this compression will be decompressed in the receiver end, and after decompression, so this data will change to this form again. Okay. So this is basically a easy method. So keep in mind one thing, I am telling you again and again, that this thing is happen when we have a consecutive repetition. There is a consecutive repetition. If it was like B A B C was A, then C, D, M. So and that, so B will be repeat but not consecutive, so it can be like B2, A10, then B1, and so on. This kind of a compressed data we also have it. Okay, so this was basically a method of a run length encoding. So hope you guys understood about it. So once you have any questions, you guys can raise it up, so I will try to solve it. So thank you for your time. See you in a next lecture.